In this new section, we look at this process called standardization. Now, standardization is simply just the conversion or the transformation of any random variable that's normal into the standard normal random variable. Now, what really happens during standardization is just a series of translation and scaling. Now, the transformation is given by z equals to x minus mu over sigma. Now, standardization is often used in a question when either mu or sigma or both are unknown. Now, let me use example 6 to illustrate this. Now, in example 6, you see x, and x is a normal random variable that has got mean 12 but unknown variance sigma square. Now, you are given that your probability x less than 8 is 0.25, and you want to find sigma. So, how do you find sigma? You start with something that you know, which is probability x less than 8 is 0.25. And then what I will do is I will transform my x into z. And how do I do that? Your z is the same as your x minus mu over sigma. Alright, so in our question, it becomes x minus 12 over sigma. So I want to make z appear in my equation. So what I'll do is I'll look at this two and I will minus mu and divide by sigma on both sides. So I will get x minus 12 divided mu, and on the right side 8 minus 12 divided mu. And this thing on the left is actually z. So you end up getting z, probability z rather, less than minus 4 divided sigma equals to 0.25. Now, once I have got this, then remember earlier on we were talking about inverse norm. If I have something like this, and if I know what B is, I can find A using inverse norm. Remember? So that's what I'm going to do here. So from the GC, okay, this is my B, this is my A. So I will use inverse norm to actually churn out this number, minus 0.6745. And this must be my A, and my A is this number. So what remains to be done is just to cross multiply and make sigma the subject. Done. Okay, so we have seen one example whereby my sigma is unknown and I've used inverse norm to find what sigma is by standardization. Let's take a look at another example. Now in example 7, you see something similar, but this time your x has got two unknowns. It is normal with unknown mu and unknown variance square. But you also have another equation. You have two equations this time. Probability x less than 10 equals to 0.3 and probability x bigger than 15 is 0.2. And you want to find mu and sigma. So again, just like the previous question, I'll make use of the information that I have. The first set of information given is probability x less than 10 is equals to 0.3. And then I can do what I just did in example 6. I can standardize. Okay, I will minus mu and divide by sigma on both sides of the original equation. Okay, remember you are only dealing with the things inside the bracket. Nothing should be done to the 0.3 on the outside. So once I do this, then this piece here is my z. Alright, so I end up getting probability z less than 10 minus mu, divided sigma is 0.3. And my z, remember, stands for the standard normal distribution. So I can again use my standardization and plus inverse norm to work out what exactly my A is. Remember, again previously, when I have z less than A equals to B, inverse norm will give me my A if I know what B is. So in this case, my B is 0.3. So if I use my GC, inverse norm 0.3 gives me minus 0.5244. Alright, so straight away I know my A is this number and A is this number here. So that's why my 10 minus mu divided by sigma equals to minus 0.5244. So now I've got one equation linking mu and sigma. Okay, but that's not enough. I need another one, and the other equation will come from this piece here. Now, rewriting the previous equation gives me this line here. Okay, so now to find the second equation, I use this px bigger than 15 is 0.2. I will, first of all, want to rewrite this as less than first, because I want to use the inverse norm function. Okay, so I'll change the bigger to less than or equals to using the complementary. Then I'll rewrite everything. I will bring probability x less than or equals to 15 on one side, and then when I bring 0.2 to the other side, 1 minus 0.2 becomes 0.8. Alright, then now I will standardize. Okay, I will minus mu divided by sigma on both sides, and then while I'm doing this, I must remember 0.8 is on the outside, so nothing happens to 0.8. Then I will apply my inverse norm, and once I apply my inverse norm using 0.8 as the number to key into my GC, I will get the number 8416. Okay, and that means my A will be 15 minus mu over sigma equals to 0.8416, and from there I end up getting my second equation. So with two equations and two unknowns, I can easily work out what mu is and my sigma. Okay, done.